All right, we are going to look at chapter 7 now. Here's the really good news. This is not a completely different standalone topic than all the factoring stuff we've been doing in chapter 6. This is all the stuff again, just with now a numerator and a denominator. So it's basically fractional factoring. And I know how much you guys love fractions.
Why do you hate us?
I don't. I was like, I love all you guys. That's the whole point. I want to share this stuff that is so much love. All right, so a rational expression is just a fancy way of saying a fraction. By definition, a fraction is, all right, a rational expression. That is the actual definition. Rational integers divided is what creates a fraction. Important note, all right, that we have discussed and we now need to continue to emphasize, 0 in the denominator, all right? That leaves the expression with what value? What is 1 divided by 0 equals what? 0. No. Undefined. So, all right, same thing. All right, variables represent numbers and you can't end up with a 0 in the denominator. So that's something that we're going to continually have to check. Now, the good news is that means in order to, for this first one, list all the numbers in which the rational expression is undefined. Oh, it says undefined right there. All right, is undefined. That means set the denominator equal to 0, or specifically not equal to 0, because it cannot be 0. That means I take the denominator and I set that not equal to 0. And then, once again, we're just solving something that we have done many, many times. All right, even though it looks more complicated, this is exactly what we have been doing. Which again, practice our diamonds. -10 and -3. What multiplies to -10 and sums to -3, Brittany?
What sums to?
What multiplies to -10 and sums to -3?
Negative. -5 and -2.
-5 and -2?
Or positive.
+2. And that is absolutely correct. Once again, I can jump straight, all right, to the factors. And basically, right, x cannot be -2 or 5. Because if I plug either of those numbers in, that would give me 0 in the denominator, right? And I could check that pretty easily. Let's check that.
5 or -5 or
+5.
So x.
And watch the check here. Okay, so just by plugging 5 in. Okay, so in the top I have 9 in the numerator. 5 squared is minus 3 times 5, which is? So 25 minus 15 minus 10, 0. which means that that ended up undefined. So all we're trying to do is identify the values it cannot be because it would make the expression undefined. And I could check it with -2 as well. All right, so again, we always want to write our expressions in the simplest terms. So a lot of our instructions, they say simplify. Especially when it comes to fractions, we want to always simplify our fractions. In order to simplify this, now you can ideally just see this, but if it ever starts to get to be numbers that you're less familiar with, do the prime factorization. And do it just for both the numerator term and the denominator term. So remember, prime factorization is breaking things up into its primes. But you start just by breaking up the number and the variable. Let's do one at a time. We could do both at a time. And then you break your number down into prime multiples, right? So what two numbers multiply to 8? 2 and 4. All right, and not choosing one. Gotta pick at least one of those to be prime. And then 4 breaks down into 2 and 2. X squared breaks down into x times x. All right, so that one's prime factored. Same thing, 24 breaks down, pick two numbers, and any two. 2 and 12. All right, whichever one is prime, you stop. Then 12 breaks into 2 and 6. And 6 breaks into, and x is done. X can't break into anything. So notice what we have. We have 2 times 2 times 2 times x in the numerator. Then in the denominator, I have 2 times 2 times 2 times 3 times x. So this is the simplest way, all right, to break this down. Now, I could also just say 8 divided by 24 is, what's the fraction?
1/3.
1/3, all right? Now, if you could just see that, that's absolutely fine. When it starts to get numbers 72 divided by, 224, this is the best method. And then just cancel it down. Let's see, an x and an x cancel, a 2, a 2, a 2, a 2, a 2, a 2. What's left in this fraction?
X/3.
X/3. Which, be aware, that's perfectly fine, and you can leave it like that. But x/3 can also be written as 1/3 x. Just to keep refreshing everyone on that. And that's all we're doing on all of these. Note, the instructions on almost everything in chapter 7 are going to say either simplify or solve. Because all we're going to be doing is reducing fractions, but now our fractions have variables in them. But don't get overwhelmed, because a fraction with 2 variables means that you just deal with the numerator, then deal with the denominator, and then you're going to do some canceling. So one piece at a time. At the numerator, all right, just looking at the numerator, how would I factor that?
6. Take out 6.
Greatest common factor, right? That is our standard method. That is our first step every time. Pull out a 6. That leaves us with x plus 2. In the denominator, Fred, what is the GCF? 7. What remains in the parentheses?
2.
A 2? That it?
No, x plus x.
X plus 2. And now, once again, in most of these situations, you're going to notice, oh, look. Now, be aware, you can only cancel numerator to denominator if things are being multiplied, right? This actually says 6 times quantity x plus 2, 7 times quantity x plus 2. Then you can cancel. It is crucially important that you have everything being multiplied. All right, do not, this is the temptation. All right, actually, let's make this x squared. This is what I see way too often. X squared plus x divided by x squared plus 7. People are like, oh, cancel my x squareds and end up with x all over 7. That is not the same. You cannot cancel across addition. Just to help you remember that, recall. 5 plus 7 divided by 9 plus 7. Can I cancel these 7s and this becomes 5/9? Yeah? Right?
So when you got the x plus 2, was that?
Okay, hold on. Let me finish this. We'll come back to it. 5 plus 7 divided by 9 plus 7. I cancel those 7s. Is that 5/9?
No, because you can't cancel them out. Right?
Absolutely not. 5 plus 7 is 12. 9 plus 7 is 16, right? So that actually is 12/16, AKA 3/4. Okay, 5/9 and 3/4 are definitely not the same number. Okay? But somehow when people have x's, all right, they want to cancel. Oh, got x squared up here and x squared down here. Oh man, that made it so much easier. Okay, you cannot cancel across addition. Everything we are going to do, all right, notice everything is being multiplied. Everything is being multiplied, and that's how you can cancel it. All right, Brian.
So when you got the x, is that just because you found the greatest common factor to?
Yes, when I did the greatest common factor in the numerator, when I pull a 6 out, that leaves an x. When I pull 6 out of 12, that leaves a 2. Greatest common factor in the denominator, pull 7 out of 7x, right? Leaves an x. 7 out of 14 leaves a 2. We're just doing greatest common factor numerator, denominator, and then seeing what cancels. But you can do more than just greatest common factor. All right, so again, just numerator, just denominator, deal with it one piece at a time and then see what you have. So looking at the numerator, just the numerator, can I factor this?
Yes.
Yes. Does anyone remember what this is? How to factor this or what this is called?
Difference of squares.
The difference of squares. Now, beware, remember I can also do diamond on this. Since I love the diamond, I'm gonna do the diamond. But I could absolutely do, just recognize that's a difference of squares. But that is a diamond, all right? And because it's kind of tricky diamond, what goes in the top here? It's only a 2-term diamond. It's one of the, we don't deal with that one a lot.
0? No, 1.
Almost,
Negative.
-1.
But.
And then 0 goes in the denominator, right? And because what times what makes -1 but sums to 0?
-1, +1.
-1, +1. So this is a tricky diamond, which is why sometimes it is easier just to identify it's a difference of squares. So that becomes x minus 1, x plus 1 in the numerator. Now, same thing with the denominator. That one is another diamond. 2 in the top, 3 in the bottom. Brian, what are the factors?
1 and 2.
1 and 2. That's once again, all right, I can jump straight to the factors. Because the coefficient in front of the x squared is 1. And then once again, notice what gets to cancel now? Does it matter that the x plus 1 is over here and this one's over here? No, because they're being multiplied. I could easily change where they are. 5 times 7 is the same as 7 times 5, right? So where these are don't matter as long as there is a multiplication in between them. I cannot cancel the x squareds right here, but I definitely can cancel these x plus 1s here. Knowing when to stop is important too. This is as simple as this gets. Okay, there's an x minus 1 in the numerator and an x plus 2 in the denominator. And yes, I can drop the parentheses because there's nothing else left next to it. Okay, Brad?
Oh, I see.
We actually did a little bit of this before. Things that are opposite, they're the same, but off by the sign only. So this is an important one to always check. What helps this a lot? Okay, the numerator's fine. What is wrong with the denominator?
It's not descending order.
Descending order helps this a lot. So always get in the habit of putting things in descending order, numerator and denominator individually. So, all right, in the numerator, x minus 4, there's nothing I can do there. Within the denominator, what can we do, Kaylin?
You can split it up into like, I don't know.
This is the one that you were asking the question on last time.
I don't even remember what question I asked.
Uh,
Oh, was it the negative X thing?
yes, all right, with the negative, all right, x, all right, I should do what factoring technique on the denominator?
Oh, you divide it by to make it a positive?
Yes, divided by specifically what?
Positive? The negative.
By the negative, right? And not really divide factor, but divide factor, sort of, they're very related. All right, so what is the greatest common factor in the denominator here? -2, right? So I want to pull out -2 there because that leaves x. And what does the second term become now?
Negative.
-4. All right, so when you, descending order is very helpful, and then identifying, a lot of times whenever possible, make that x term a positive just by pulling a negative. And once again, I can see I have an x minus 4 here and x minus 4 here. Definitely there's a -2 left in the denominator. What's left in the numerator? 1. Remember, there's always a 1 there, okay? And so that becomes 1 divided by -2, or -1/2, or -1/2. Remember, all of those are equivalent as well. This is one of the things I see that, like, it feels like this is so easy, and I see people, I don't know where the negative, well, -1/2 is the same as 1 divided by -2, which is the same as -1/2, right? That negative can go numerator, denominator, or out front. All right. Ooh, this is a really fun one.
Looks fun.
It does look fun, I agree.
It looks like a skip problem.
All right, so it looks like a skip problem. Yeah, I mean, you get a few of those, but don't get excessive on them, right? Okay, so I was like, if you're skipping the hard algebra ones and the word problems, all of a sudden you're the number of skip and the graph ones, well, you've skipped a lot of the test. Okay, so basically the first and the last terms in both the numerator and denominator, there's not much to do with, but we'll write those out in just a minute. The middle terms on both of these, all right, what are they? They're quadratics, which means that the middle terms on both these, numerator and then denominator, all right, we need to diamond them. And then we're gonna write them out. So for this guy, that's a 1 and a 2. Maddie, what are the factors?
1 and 2.
What are the factors? 1 and 2? One time, okay, let's just do it. 1 and 2.
Sorry, you caught me off guard.
If I put 1 and 2 in there, 1 times 2 becomes?
Oh, I did it the opposite.
You
One
did
and
do it
one.
the opposite. So let's do it again. What are the factors?
1 and 1.
1 and 1. Okay, so writing out the top, and this can be helpful as well. T plus 2 cubed. That means T plus 2 times T plus 2 times T plus 2. All right, this now becomes, because this guy becomes T plus 1 times T plus 1. So that is the whole numerator expanded. All right, everything being multiplied out. Now, do you have to break those cubes down? Of course not. So you could do the exponent math, right? But I see that that is helpful a lot, all right? If things are getting too complicated, break it into its simplest terms. That's what factoring is. Breaking everything down into basically I have 6 1-degree functions. All right, so similarly, all right, for the denominator, t plus 1 times t plus 1 times t plus 1. Gonna have 2 terms in there, and then a t plus 2. That diamond is 4 and a 4. Hannah, what are the factors? 2 and 2. What is super awesome about this problem?
What?
This becomes a 1. I see 3 t plus 1s on the bottom, 3 t plus 1s on the top, 3 t plus 2s on the top, 3 t plus 2s on the bottom. Oh my gosh, it all cancels. So satisfying. Is that problem worth skipping? The answer was literally 1. Right? Don't get overwhelmed. Breathe. Because look how sometimes it just becomes the best answer there is. 1, 0, or infinity. Those are the best answers. Everyone okay with that? All right, we will call it there. We're gonna have some hefty lectures next time.